will start the next section, which is modeling of linear equation. Right, what we are going to study this section. In this section, we will present two types of application for the first order differential equation. راح نعرض عندنا هون بهذا المثال section two different types of applications for the linear or first order differential equations in general. I mean, we will present two different problems, and those problems, to solve them, you have to create a differential equation. The differential equation becomes linear, then you have to solve it as a linear or a first order differential equation in general, as a separable, linear, homogeneous, exact, or non-exact. But before we start, you have to understand that the differential equation branch of mathematics was created to serve the physicians who were facing a problem. I mean the physics people who were working in any phenomena or any nature problem. They are facing that when they try to transfer their problem into mathematical symbols, it becomes a differential equation. It could be first order, second order, or a higher order. Of course, for the second orders, we will have an applications in general later on. And in this section, I will present just an application for the first order differential equations. Of course, we have many applications, many applications for the differential equations, but we will present two types here. But before we thinking for any problem, I have to determine my assumptions and hypotheses in my problem. Then I have to transfer my assumption and hypothesis, the problem according to my assumption and hypothesis, into a differential equation. Now this differential equation, I have to determine which type and how we can solve it. Then we have to solve it. After you solve it, you get you obtain the solution. And you can check your solution. You can check your solution by applying the solution to the original problem. We will follow this procedure for the first application of the first order differential equation, which is heating and cooling problem. Let us to study the problem, to assume the assumption, determine the hypothesis, and transfer my problem into differential equation. Here, the problem of the heating and cooling says that المشكلة بتقول عندي كما يلي. According to the Newton empirical law of cooling and warming, the Newton law about cooling and warming says that, starting from here, the rate at which the temperature of a body changes is proportional to the difference between the temperature of the body and the temperature of the surrounding medium. And that's enough. We finished here the Newton law. Before we start the Newton law, assume that you went to the fridge and you grabbed a can of juice. The temperature of the fridge, assume that it was the temperature of the fridge here minus 20 Celsius degrees. But the room where you are sitting to drink your juice, the temperature of the room, it was, for example, 12 Celsius degrees. This is the room. If you brought this can of juice from the fridge, and put it in the room temperature, you will see that the temperature of the can of the juice will be increases and arrives to the temperature of the room, which is here 12 Celsius degrees. But how long it takes for the time t, I mean here I'm talking, for the can of juice to be heated to be the same as the degree of the room? This is our problem here. How we can create an equation or transfer the Newton equation, Newton law for cooling and warming into a function of time t. Let us to read. خلينا نقرأ مرة ثانية. The law says the rate at which the temperature of the body change is proportional to the difference between the temperature of the body and temperature of the surrounding medium. Here I have a temperature of a body, a temperature of the surrounding medium. Medium here, I mean, in my example here, it was the room. All right. Now, let us to assume that T capital of T small, this is to represent the temperature is a function which represents the temperature of any object at any time t. Tm is the temperature of the surrounding medium, like the room in my example. الآن when I have T is representing the temperature of the body or the object at any time t. هلا when we derive D capital with respect to D small, what does this means? In calculus 1, dt by dt, what does this mean here in this problem?
We are differentiating capital T with respect to the small t.
We are differentiating
A big T with respect to small t.
Yeah, I mean, okay, you differentiate, but in my question here, what does this mean? Who can answer?
It's the rate of change of capital T with respect to
the rate of changes, of the temperature of the object with respect to the time t. This is rate of changes of t with respect of t. Right. I'm just translating here. So go back to the law here. Is the rate at which the temperature of the body changes. This is represented by D capital, dt capital by dt small. طيب, continue. Is it proportional? Proportional to what? Proportional, it means there is a K constant. This is what I mean proportional. To difference between where? The temperature of the body and the temperature of the surrounding. Difference. He said difference. This is difference. Temperature of the body and the temperature of the surrounding. It becomes T minus Tm. So in this case, I translated the Newton law into a differential equation, becomes now in this form. I translated so it becomes now a differential equation. This differential equation now is a first order differential equation. First order differential equation. K is the K constant here, represent the constant of a proportionality. طيب خلينا نشوف الآن. Let us to see how I can apply this in Newton law to the following examples. The example says, when a cake is removed from an oven, you have a cake removed from an oven. Temperature inside the oven, it was high. Its temperature is measured at 300 Fahrenheit degrees. It is measured 3 Fahrenheit degrees. 3 minutes later, its temperature becomes 200 Fahrenheit. What does this mean? That T of 3 minutes is equal to 100 Fahrenheit degrees. But when it was removed from the oven, its temperature, it was 300. That means T of 0 is equal to 300 Fahrenheit degrees. The question says, how long it will take for the cake to cool off to a room temperature of 70 Fahrenheit? So the question now becomes, what's the time T such that the temperature is equal 70 Fahrenheit degrees? This is the question. But the temperature of the room, how much is that? Tm. Also, it is 70 Fahrenheit degrees. Because the temperature of the room, the surrounding medium. So now you can determine, we determined in this case the given information. Now I have to go back and to write that directly. dt by dt is equal K times T minus Tm. You have to substitute the value of Tm only. dt becomes now dt K times T minus 70. Now solve this differential equation. Solve this differential equation. You can solve it either by separable or linear. Any one of them, it's work. Then dt by dt is equal kt minus 70k, which implies that dt by dt minus k times t is equal minus 70k. Now I wrote it in this form to be linear differential equation. We have to solve it as linear. Find the mu of t. e to the power integral pt, which is e to the power integral minus k the dt, which is e to the power minus kt. A solution tt capital is equal 1 by e minus kt times c plus integral minus 70 k times e to the mu, which is e to the power minus kt dt. Definitely I need one more page. Right. So t of t is equal e to the power kt times c plus. Now what's the value is equal here? يلا نشوف. What's the integral? Take a 70 outside. Integral minus k e to the power minus kt. It is e to the power minus kt. Multiplied becomes c times e to the power kt plus 70. So I found here, and this is the equation. What does this equation represent? This equation represents the temperature of the cake at any time t. Now the first thing I have to do is to find out the value of the constant c, then to find out the value of k. طيب الآن to find the constant c I have to use what? The initial condition t of 0. To find the constant c, use t of 0 is equal to 300 Fahrenheit degree. So that means 300 is equal t of 0, which is c e to the power 0 plus 70. So 300 is equal c plus 70 means c is equal to 30. Now substitute the value of c again. Here becomes tt عبارة عن 70 plus 230 times e to the power kt. Now, how I will find the value of k? Use the other given information, which is, he said after 3 minutes, I mean t over 3 is equal to 100. Use t of 3 is equal to 100. Therefore, 200 becomes t over 3, which is 70 plus 230 minus e to the power 3k. 70 out of 200 becomes 130. Divide by 230 is equal e to the power 3k. That means take ln for both sides. 3k is equal ln of 13 by 23. So the value of k, 1 by 3 ln of 13 by 23 which is approximately is equal minus 0.19. So this is the constant K. Substitute back here where? Back here. The value of K. This one becomes now TT is equal 70 plus 230 times e to the power minus 0.19 t. So this equation here represents the temperature of the cake at any time t. هلا now go back to my question. My question says when the temperature will arrive to 70 degrees. This is my question. Now I have to solve T of t is equal 70 degrees. يلا متى بيكون 70 degrees?
The value of time will be 0.
I mean you have to solve it for the time. صح?
Yes, correct.
All right. Listen to me. To solve it in the time, I'm sure the students will say the following. 70 is equal T of t, which is equal 70 plus 230e minus 0.19 t. But in this case, you will cancel 70 minus 70 implies that 0 is equal to 30e minus 0.19 t. And this is what? This is impossible. This is impossible. Because the exponential all the time positive value times positive cannot be equal 0. But how I will solve? I will solve this one. But note that if you take the limit of tt when the time t goes to infinity is equal what? It becomes a limit of 70 plus 230 e minus 0.19 t, where t goes to infinity. Hello, where t goes to infinity, this limit becomes, because of the exponential negative, so it becomes 0, so that becomes 70. What does this mean? This means Tt, the temperature, will be close to 70 for large value of a time t. This is, I'm translating here, when I talk limit, it means the limit when t goes to infinity, which means that when the time becomes very large, then the temperature becomes to 70 degrees. For example, if you take here t of 30 minutes, it becomes 70.77. But if you take t of 60, becomes 70.0026. Now, if you take t of 100, here, becomes 7.000013, which means that if you increase the time t, you will see that this fraction becomes very close to 0. So the temperature becomes very close, or yes, very close to the temperature of the room, which is 70 degrees. Is it clear, this example? It's very simple and straightforward to apply, but you have to be careful when you read the information, the given information. When you read them from the problem, you have to be careful about that.
Doctor, can we please stop here, because we need a chance to pray before the lab. So we have lab in 10 minutes.
Yes.
Thank you.
Take an attendance, please.